and welcome to the GMAETS 41's live stream class. We are going to give attention to chemistry in this class today. Now, to use this opportunity to welcome our dear students, I'll be giving a little moment to have you friends join the class as we kick off chemistry past question and answer review, as well as expected exam focused questions. So we shall be looking at this part of chemistry covering atomic structures, covering valency, and of course, based on the question that Group 3 dropped in our, our WhatsApp group, I will also be giving attention to, I think, something about isotopes, because I saw something of that kind. So I am waiting for you guys to join as we kick off this class. Once you join the class, you can just indicate your presence. As I notice, somebody has joined. So I am still waiting as I kick off the class. I'll be dropping the link in our WhatsApp group. Once you join, you can also share the link to others. Once you join, please indicate by saying, "Hi, I can hear you." All right? Once you join the class, please indicate. You can leave a comment to show that you are here. Can you hear me? You can say 3 persons having joined the class. If you can hear me, give the video thumbs up so I can kick off with the class, please. All right, Chinwe, that's good. Thank you for the message. You can share the link to this live stream past question review class to others as I kick off this class. All right, I remain the GMAETS. You're welcome to the GMAETS 41's live stream section as we kick off with this 2025-2026 exam focus questions. All right, as usual, this is in line with our previous work from our physical class, all right, our physical JAMB lesson class. But I also want to say that online here on YouTube, we also have our online classes here on YouTube, okay? So these questions, I can see about 20 questions dropped by Group 3 of the GMAETS 41's JAMB lesson group. Okay, now I want to also apologize to any other person that is joining this class who is not a member, that we already have these questions, all right, dropped in our WhatsApp group. And so I'm going to simply dictate the question. You can follow through, then dictate options and provide answers to them. Any possible explanation I can give to it. Okay, to become a member of this class, what you have to do is simple. You can join us by clicking the join tab, all right, on the channel, and of course become a member of our class. Okay, so we'll be moving on straight to our very first question. So the first question here, I've got this. Consider the species. Consider the species 72 zinc, 75 then AS, guess arsenic, and 75 GE, I guess germanium, right? And these species have, now this is what we've got there. Our first question, gosh. So we have something like 72 zinc. I think that's what I'm saying. Then we have 75 arsenic. Mind you, I'm writing exactly what was dropped. If the question is that which makes sense, then I'm going to give response to it. This is what was provided. Okay, so these species have A, the same number of electrons, B, the same number of protons, C, the same number of neutrons, D, the same number of neutrons and protons, and then E, the same mass number. Sorry, that the first thing I want to say here before going for what likely can be the answer to this question is the fact that given this, right, I assume that these are their mass numbers. I'm assuming that because normally if an atom is given in this format, this happens to be the mass numbers written on top. Okay, that's what I feel based on what was given. All right, and since these species are different, they can never have the same number of protons. They can never have the same number of protons. That's one thing you want to take note of. Then secondly, they can never have the same number of electrons. They cannot, because for a neutral atom, the number of protons and electrons are the same for an electrically neutral atom. So these guys cannot have the same number of protons. They cannot have the same number of electrons. Okay? And the only person, if they don't have the same mass number even, take note. Looking at this as their mass number, supposedly, because I'm working in line with what was given in that question, which, like I said, it really doesn't make any sense. However, that it doesn't make any much sense to me based on what was presented. However, I think there is this option. Now, let us assume that this question is actually correct. Okay, this option C, the same number of neutrons, seem to make sense. Are you following, right? Option C, the same number of neutrons. Because like I said, their proton number cannot be the same. These are different atoms. Their electron numbers cannot be the same because these are different atoms. However, if we knew the atomic numbers, suppose the atomic numbers were given to us, we could have done the mass number minus atomic number, mass number minus atomic number, mass number minus atomic number, and then check what their number of neutrons would be. It is likely possible for their number of neutrons to be the same. Because sometimes we have what we call isotones. Isotones in chemistry, right? Like you know about isotopes. We have isotones. We have isobars. For isotones, they have the same number of neutrons. They have the same number of what I said, neutrons. But their mass numbers might be different. Okay? However, their number of neutrons will be the same. The atomic number will be different, you know, something of that kind. So that's what I'm thinking of about this question. The options provided, option A is not the answer. That I'm 100% sure because these are different atoms. They can never have the same number of electrons. Option B, we have the same number of protons. It's not possible. Reason again, because these are different atoms. Okay, now option D, let me jump C and go to D because C is what I'm thinking is the answer. D, the same number of protons and neutrons, all right, the same number of protons and neutrons. Okay, that is atomic number is the same as proton number. They can never have the same number of protons. They are different atoms, okay? Then the same mass numbers. Clearly, from these numbers given, they are not the same. These are their mass numbers, right? So their mass numbers are not the same. And you see, we are left with option C. And in option C, there the same number of neutrons. From what I explained, based on the concept of isotones, it's likely possible that these guys have the same number of neutrons. I say likely possible. You know why? I cannot conclude because I do not know the atomic numbers. The atomic number was not provided. So the group leader of group 3, right, Ugochukwu, you can look at that question, and possibly I would like to see the source directly to know why the question was presented in this format. All right. Okay, having said this, but remember, supposedly I am looking at option C, the same number of neutrons. Let's move on to question number 2. The neutral atoms of all of the isotopes of the same element have, I take that again, the neutral atoms of all of the isotopes of the same element have A, different numbers of protons. That is not possible. B, equal number of neutrons. That is not possible. C, the same number of electrons. I'm going to pause at that. While likely I'm thinking that to be the option, I don't just want to say option C is the correct answer. I will have us analyze it so that it can make sense to you. Now let me read option D. The same mass numbers is not possible. And then option E, the same masses is not possible. The same masses, the same mass number, they're the same thing. So that is not possible. Now, the correct answer from here is the same number of electrons, which is option C. Why is that so? Let's go back to the question once again and pay attention. The neutral atoms of all of the isotopes of the same element have. So what should you know about the isotopes of the same element? When they are neutral, they have not reacted. These guys, they have the same number of protons. That is one thing you should take note of. They have the same number of protons because their atomic numbers are also the same. If I give you, say, okay, the one that most times as educators we use as example when teaching isotopes. If I give you the isotopes of chlorine, for example, all right, we have chlorine 35. We have chlorine 37 in terms of the mass numbers, right? Now, the atomic number of these two guys that have different mass numbers or different atomic mass, 35 and 37, their atomic numbers are the same. And once atomic number is the same, it means that the proton numbers will also be the same. Why? Because number of protons is the same as number of, that is the same as atomic number. I take that again. The number of protons of an atom is the same as the atomic number of that atom. In fact, whether that atom is neutral or not, the number of proton and the atomic numbers are the same. Now, if you look at option A, we are told different numbers of protons is not possible. Option B say equal numbers of neutrons. As a matter of fact, as long as the mass number, are you following right, of isotopes are different and they have the same atomic number or proton number, their neutron number can never be the same. Am I communicating? And I hope you are learning something, right? That is why option A and B are off, which said different numbers of protons. Isotopes, their neutral atom have the same number of protons, not different. So option A off. B, equal numbers of neutrons is not possible once the mass numbers are different. Let me just analyze this with chlorine 35 and 37, like I said. 35 and 37, okay? The atomic numbers of these guys, which is the same as proton numbers, are 17, 17. So you can see the same proton number, the same atomic number. And if the number of proton of a neutral, if a number of proton rather, I give you an atom which is neutral, the number of proton of that neutral atom will be equal to the number of electrons. Okay, so that option C that said the same number of electrons is the correct thing. Now, let's prove it. Proton number 1717 simply means that electron number is also equal to 17. And that is the same, as you can see. Let's check for the proton. Proton is also 17. 17, 17. They are not different. Are you following right? Let me indicate it. 17, 17, electron. Atomic number, we use Z for atomic number, is still 17, 17 because for a neutral atom, the number of electron is equal to the number of proton and is equal to the atomic number for a neutral atom. I hope you're following, right? So having established this concept, let's look at the neutron number, the neutron. For chlorine 35, for example, 35 minus 17 is going to give us 18. Then 37 minus 17 is going to give us 20. So you see that the neutron number are different. And then if you now talk about the atomic mass or the mass number, you can see clearly 35, 37 different. Okay, so that is why the correct answer to this question, is option C, the same number of electrons. Option A, B, D, and E are off. All right. We are moving on. Who is this person? Definitely not our student because the name is not familiar. Adebi Fumilola. I do not want to learn. You have to learn, oh. Right? You have to learn. Learning is good for you. Especially if you are preparing for your exam, JAMB and WAEC, or maybe school exam. It could be semester exam in 100 level, right? You have to learn, okay? All right, welcome to all the friends that have joined so far. If you're enjoying this lesson and this explanation, give this live stream class a thumbs up. Like I've always advised you, share the lesson to your friends, to your colleagues, so they can join this class. There is no time. You see, education or learning should not just end in the four corners of a building called class. From the comfort of your home, you can always learn. That's the truth. Technology has made this quite easy. All right. So invite your friends to join us, okay? Invite your friends to join us. Share this link to groups that you are a member of. But please don't share to our group again if you are. All right, don't share to our group because I already shared the link to the GMAETS 41's WhatsApp group where these questions are coming from. Like I said, the questions we are answering, about 20 of them, okay, is questions applied by group 3 because we have different groups formed for our students. All right, guys, let's move on to question number 3. The maximum number of electrons that can be accommodated in a subshell for which L equals 3 is, I take the question again, the maximum number of electrons that can be accommodated in a subshell for which L is equal to 3 is A, 2, B, 10, C, 6, D, 14, E, 18. This is interesting. This question is actually taken from quantum numbers. I remember having taught my university student in 100 level the concept of quantum numbers. But in our JAMB class, we've really not touched that. Although I made a little reference to that when I taught the concept of periodic table, when I taught the concept of atomic structure and valency. I made a reference to that, but we've not handled it fully. However, one of you have decided to add up this question, and it's interesting. Remember, this is past question review in preparation, right? As per exam focus of the next exam cycle that is coming. So it doesn't matter the question that has been presented, as long as it is still within the range of related topics considered. I will accept that and will duly give response to it. Now we are talking about the number of electrons that can be contained in the subshell, given that L is equal to 3. What should you know about that guy L? That L, which is subshell, is actually called the azimuthal quantum number. It's also called the orbital angular momentum quantum number. We also call it the subsidiary quantum number. So I want to take note of this. At the end of this live stream, a copy of this video lesson is going to be made available, so you can still come back and rewatch it. so you can be able to take down some necessary notes. Are you following, right? So that L given to us is equal to 3. We call it azimuthal quantum number. We call it orbital angular momentum quantum number. We call it subsidiary quantum number. It is actually quantum number 2 in the study of quantum number. There are 4 of them. Principal quantum number is the first one, which gives us information about the shell, the energy level of an electron. It also tells us about the distance of an electron or shell from the nucleus. Then we talk about the azimuthal quantum number, which gives us information, of course, about the subshell of an electron. All right. It also describes the shapes of the orbital of a subshell. It describes the shape of the orbital of a subshell, where we talk about the, the spherical shape, the dumbbell shape, the double dumbbell shape, the complex geometry in the case of SPDF. On the GMAETS 41's channel here, I have a video dedicated to quantum numbers. You can do well to take it. All you just have to do is slide through the GMAETS 41's chemistry playlist or Chem 101 playlist, because that video was actually linked to that of advanced level 100 level student. But you can see now JAMB WAEC can also test you on some of those stuffs. Besides 100 level student do much of SS1, 2, and 3 works. So let's go straight to this. But I've mentioned 2 of the quantum numbers. We also have the third quantum number called the magnetic quantum number. And the fourth and last one is the spin quantum numbers. The magnetic quantum number tells us about the orbital of a subshell, right? And the way they are arranged in space. Then finally, the spin quantum number gives us information about the direction of spin of an electron, whether it is spinning spinning clockwise, or anti-clockwise. If you place an electron, you draw it upward, that is clockwise spin. Downward is anti-clockwise spin. So with that, we have L equal to 3. Remember, this is azimuthal quantum number I said. We are asked to calculate the maximum number of electrons that guy can take. So the maximum number of electrons that a subshell can take, that the azimuthal quantum number can take, is equal to 4L plus 2. You can still use the formula 2L, 2 brackets 2L plus 1. Are you following, right? Any of this formula is okay to use. So this is going to be 4 times the value of L, which is 3, and then plus 2. 4 times 3 is 12, and then 12 plus 2 is going to give us 14. So this subshell with L equal to 3 can contain a maximum of 14 electrons. Let us look at the options provided once again. Option A is 2, option B is 10, C is 6, option D is 14, option E is 8. So you see clearly that the correct answer is option D, which is 14. All right, Favor, you're welcome. Ebere, you're welcome. Confidence, you're welcome. Gift, you're welcome. I hope you're learning something. Benson, you are welcome. If you have any question, remember, you can always drop your question there in the comment section. I will respond to your question if there is anything you don't understand. And don't forget something. Recently, the GMAETS 41 embarked on a serious program. Making lots of video lessons available for students on the GMAETS 41's YouTube channel. They introduce most of all these topics in physics, in chemistry, in maths. They are available on the GMAETS 41's channel now. So on your own, you can just simply slide into any of the playlists for the subject, search for the topic, and take a lesson on it, while we still continue with our physical classes. But one thing I want to always assure you people, and I always encourage students, is you cannot overemphasize the importance of online learning. Why? Because right from the comfort of your home, when your brain is calm, when you are relaxed, you want to study, you want to take in stuff into yourselves, right? You want to take in knowledge. You can do that just right from the comfort of your home. And that is one thing that the GMAETS 41 is committed to providing for our present generation. Talk physics, chemistry, and maths. You can always count on the GMAETS 41. So these stuff I'm analyzing, although some of them we may not have done, like this one, we've not treated it in class. This one, we have touched it in class, right? This we have not. But you can learn about it while waiting for the day that it would be its turn to be dealt with. Like I said, this is based on quantum numbers. This will take us to question number 4. Question number 4. All right. In that question number 4, we have this read. A neutral atom of an element. A neutral atom of an element has 2 electrons in the first energy level, 8 electrons in the second energy level, and 8 electrons in the third energy level. This information does not necessarily tell us, I'm going to dictate the option, but before then, let's see what the question is much about, right? When you hear energy level, that is where principal quantum number comes in, and the first energy level have n equal to 1, and then the next n equal to 2, the next n equal to 3. They give us up to 3 energy levels. That corresponds to our subshell, K, L, this subshell or shell rather, that corresponds to our shell, normal shell when you're drawing atomic structure. N equal to 1 is the K shell, N equal to 2 is the L shell, N equal to 3 is the M shell. So if you're drawing atomic structure, you have something like 2 electrons here, the second shell, 2 electrons, the third one, the second one is 8 electrons, the third one is 8 electrons in that order. So the first shell can contain a maximum of 2, then the other is a maximum of 8. All right, so this is just the interpretation of what that question is all about. A neutral atom of an element has 2 electrons in the first energy level, 8 in the second energy level, and 8 in the third energy level. Now the question said, this information does not necessarily tell us, option A, the atomic number of the element. The information tells us about the atomic number of that element. Yes, it tells us. So that is not the answer, because what the examiner is interested in this question is, now you have been given this information, right? What can this information not give to you? What information can it not provide? That is what we are looking for. And option A said, okay, this information does not necessarily tell us the atomic number of the element. It's not true. This information tells us about the atomic number of this element. As a matter of fact, 2 plus 8 plus 8, which, this is the number of electrons in each shell, in each energy level. So if you add up this, you get 18. This is atomic number 18, argon to be precise. So option A is saying it does not necessarily tell us the atomic number of the element is not true. It gives us that information. Now B, this information does not necessarily tell us anything about the element's chemical properties. It really tells us about the element's chemical property. It tells us about that. Yes, it tells us about that. You see, when you know that you have 2,8,8, this energy level is completed already. And then we know that it is a noble gas. Therefore, in terms of chemical reaction, we know that noble gases do not undergo chemical reactions because they have completely filled outermost shell. They have completely filled energy level. So from this energy level, we know that these guys, the outermost shell, the valence shell, the ultimate shell is complete. And so it does not react chemically. So we get that information from there. Let's move on to C. This information does not necessarily tell us the total number of electrons in s orbitals. It does not tell us the total number of electrons in s orbitals. I think I'm going to come back to that anyway. I'm going to come back to that option. Then D, this information does not necessarily tell us the total number of electrons in p orbitals. We are still going to come back to that. And then E, it does not tell us the number of neutrons in the nucleus of an atom of the element. It does not necessarily tell us the number of neutrons in the nucleus of an atom of the element. Of course, with this, we can actually find out that this is argon, like I said. But when you have atomic number, because this thing you have here gives you atomic number. This thing you have here gives you what? Atomic number. If I give you an atom, and I give you the atomic number of that atom, except you know the mass number, you cannot get the number of neutron. I repeat, if I give you the atomic number of an atom, because, see this guy here, 288, this is the number of electrons in each of the energy levels, in each of the shells. And with this number of electrons, I already know the atomic number. But if you know the atomic number of an element, does that necessarily tell you the number of neutrons that that element has? The answer of manganese, let's assume to be 25. Manganese is atomic number 25. And then you don't know the mass number. You don't know the atomic mass, that one written on top of manganese. There is no way you can get the number of neutron. Even like this guy now, yeah, we know the proton number, we know the number of electrons, we know the atomic number. And I even identified the element to be argon. But now, given that you don't know the mass number of argon, there is no way you can get the number of neutron. That's what I am proposing. That's my argument. So, I will conclude, this information does not necessarily tell us the number of neutrons in the nucleus of an atom of the element. It does not. It does not. Look at option C, the total number of electrons in s orbitals. Once you know the number of electrons in the shell, you can actually go ahead to break down the number of electrons in s orbital. If you know the total number of electrons in the shell, it can also go ahead for that option D. It can go ahead to tell you the number of electrons in the p orbitals. So option A, B, C, and D are information that we can get from what was said about this element. But that option E, the number of neutrons, we really cannot get it. To get the number of neutrons in the nucleus of an atom, you must know the atomic number of that atom and the mass number. Here we were presented with only the atomic number. So we can't get the neutron number except we know the mass number. Somebody can say, but we know the element already. So from the element, can't we get the number of neutron? Now I'll ask you this question. Do you know the mass number of all the elements without being told? Because these things, you get them either from tables or examiner gives them to you. In exam, anything you have to do with mass number, possibly it has to be given to you. Because most times we don't memorize those mass numbers because of the way they are obtained. Okay? They are not meant to be memorized. We have standard textbooks or through online from which you can get these mass numbers. So except the mass number is given to you, knowing the atomic number is not sufficient, is not enough for you to determine the neutron number. The question is a bit technical anyway, but I hope I've been able to break it down as the case might be. All right, we shall be moving on to question number 5, right? So moving on to question number 5. The combining capacity of an element is known as its, I take that again. The combining capacity of an element is known as its A, valency, B, oxidation number, C, valence electron, D, none of the above. The correct answer is valency. Valency is defined as the combining power of an element. Valency is defined as what? The combining power of an element. And so that's the correct answer there to question number 5. Valency. That is straight on, clear as it could be. We already treated that in our class. Question number 7. Before moving on to that, I'd like to have you look through this because I'll soon wipe this part of the board. All right. I'll make the analysis of question 7 here. If you have any question, feel free to drop the question. I'll respond to it. Okay. Thank you very much, F Plays Z. Sir, you teach great. Thank you. I appreciate. We give all the glory, the honor, and the praise, and the greatest thanks to our God and helper, Jehovah. He is the one who gives us the strength and the wisdom to assist ourselves. Thank you very much for the commendation. F Plays Z. That's what I'm saying here. Thank you. Okay. Let us move on to question number 7, like I said. Question 7. Let me make use of this part, because of the placement of live stream. Usually you can cover a very wide range of space. The 7th question reads, which of the following correctly represents the electronic distribution in the magnesium atom? I take the question again. Which of the following correctly represents the electronic distribution in the magnesium atom? Now listen to the options. A, 3, 8, 1. Of course, that's not the answer. This is what almost all of us would already know. We've treated this very well in class, okay? It's all about electronic configuration of an atom. Magnesium is atomic number 12. So with that, if you're drawing the atomic structure, now what will be the electronic distribution in each shell? Just like we have this 1288. Are you following? Okay, so option B, 282. Option C, 183. I can't see option D here. I don't know which exam body will provide option A, B, C anyway. But it doesn't matter. Thank God the answer is there. Option B is the correct answer. Electronic configuration or distribution of magnesium is 2,8,2. There are 12 electrons in magnesium shell. Okay, so the first shell would take a maximum of 8. The second shell takes a This is not funny. The first shell takes a maximum number of electrons of 2. The second shell takes maximum of 8. And then the third shell for magnesium will take 2. So that if you add them together, you get 12 electrons. So that's a straightforward question, okay? Let us look at question number 8. But before that question, I'd like to wipe this part of the board because I need to write some things on the board there. All right, question number 8. Which of the following are true for an element? Which of the following are true for an element? Now, there is this type of question that's usually being presented by examiner. Now, they gave us I. Okay, atomic number equals proton number plus electron number. I'm trying to abbreviate. They were written in words here. Then we have II, mass number equal to number of protons plus number of neutrons. Then we have III, atomic number equal to number of protons plus number of neutrons. then IV, atomic number equal to number of protons plus number of electrons. Good. So these are the parameters, let's assume, all right, given. And the question said, which of the following are true for an element? These are the things they want us to find out, the ones that are true. Option A, atomic number is equal to proton number plus electron number. That is not true. Atomic number is not equal to proton plus electron, is not. Rather, atomic number is equal to proton number. And if the atom is electrically neutral, that is to say it has not reacted, then atomic number will also be equal to electron number. So all three will be equal. Atomic number equal to proton number equal to electron number. If the atom is electrically neutral, it has not reacted. But here, the first one said atomic number is equal to proton number plus electron number. That is not true. The examiner is asking us which of the following are true for an element. So I, we kick it off. Then I, mass number equal to proton number plus neutron number. That is very correct. The mass number of an atom, how do we get it? It's simply go to the nucleus of an atom and add up the nuclear particles. The nuclear particles are protons and neutrons. If you add the protons and the neutrons, which are found in the nucleus of an atom, if you add them together, you will get the mass number. So this second point here is true. Let's move on and see if there's another one that is true there. I. Atomic number equals P plus N. Atomic number equals proton number plus neutron number. Is not true. Is not true. Then this one, I think there's something I didn't write there. Atomic number, yep. Atomic number equal to proton number plus number of electrons from what I'm seeing here. Okay, atomic number equal to number of protons plus number of electrons. That's the last one. How come the last one is the same as the first one? How come the last one is the same as the first one? I guess something is wrong with this question. The provider, group 3, take note. This question number 8, something is wrong, okay, with it. Because the only thing I'm seeing here that is correct is I. However, these are the options provided. A, I, and I. I is not true. I've explained that already. But maybe I think I would see what we can do about this question to get something that is realistic. B, I and I. That's not true. C, I and I. That is not true. And then D, I and IV. I is correct. I was actually thinking of something here, that it's possible that this is atomic number equal to proton number equal to electron number. That's what I think. Okay, that is what I think. But let me assume I don't want to correct anything in this question because I was not the one that provided this question. These are questions from students which are exam related. Yes, classical exam questions. All right. And so we have to deal with them. So let me just not correct anything. I won't correct anything. I will just conclude that the correct answer is not here in this question. The options provided, there is none that is correct. The only correct thing here is that mass number is equal to proton number plus neutron number. So let me indicate no correct answer, no correct option. No correct option. But remember what I explained about number of, that is atomic number being equal to proton number and also being equal to electron number for an electrically neutral atom. Let's take our last two questions, okay? This we have done well for this part of chemistry. There are 20 questions actually. We've touched half of it. You know, this class is a continuous class. We'll round off with chemistry and look at English as per what has been dropped for us to deal with. Question number 9. Elements with valency 1. Elements with valency 1 are A, always metals, B, always metalloids, C, either metals or non-metals. D, always non-metals. This question is dicey. It's a tricky question, right? It's a tricky question. You know why? I'm going to read the question again. I'll tell you something. Because of two options here, elements with valency 1 are A, always metals. That is my first thought as per the answer to this question. I'll tell you why, because I think, of course, at the end, that is what we are going to go for. But hey, don't be too quick yet. D said always non-metals. Okay, C said either metals or non-metals. Yeah, C, either metals or non-metals. That one is another option that I'm just looking at. But I want to come up with the reason why I don't want to go with that one. When you are talking about valency, the truth is, valency is either positive in number or negative in number. Now, the number that was provided, the element with valency 1, what I'm seeing here is positive 1. There was no minus there. It is plus 1. I'm saying this because metals have valency of 1. Non-metals also have valency of 1. I will tell you group 1 elements, which are metals. Example, lithium, example, sodium, example, potassium. Their valencies is plus 1. Right? Okay. Now, when you move on to group 7, halogens, their valency is also 1, but it goes with minus. So we can actually say, okay, either metals or non-metals, they have this valency of 1. But hey, I think examiner wants us to respect the use of signs with these guys, right? Examiner wants us to respect the use of signs. Otherwise, we'll be having problem with option A and D together with option C. Therefore, following my explanation, please note, metals, they always have valency of positive. And whenever I hear a valency of 1, it's actually for elements in group 1 of the periodic table. And these elements are metals. Therefore, we conclude that elements with valency 1 are A, always metals. When the valency of an element is 1 or 2 or 3, these guys are usually metals, okay? So have that in mind. Have it in mind. I don't want to go for option C, and I've given my reason. Anyone else that have a different opinion can come up, then we reason it together. Are you following, right? I've explained the reason. If I go with either metals or non-metals, either metals or non-metals. This is tricky, you know. Very dangerous question. Just a kind of choice has to be made here, right? Choice has to be what? Made. I've explained. I've given the fact that, yeah, metals, they have valency of 1. Non-metals can also have valency of 1, but sign matters there, right? Sign matters. All right, so we'll be going with option A. They are metals. Valency of 1 is metals. Okay, yeah. I gave my reason for this. So anyone that has a different opinion to this should please give his own reason, that we know what to do. The last question I want to consider, question number 10. An atom with 3 protons and 4 neutrons. An atom with 3 protons and 4 neutrons will have a valency of A, 3, B, 7, C, 1, D, 4. The correct option is A, 3. Go back to the question. An atom with 3 protons and 4 neutrons will have a valency of, first of all, when dealing with valency of an atom, you have no business with neutrons. I repeat, you have no business with what? Neutrons when dealing with the valency of an element. So telling us it has 4 neutrons is of no use to us. Kick that information off. Focus on the number of protons, because the number of protons go ahead to give you the information about the number of electrons. Now we assume that this atom is electrically neutral. So if that atom has reacted, if it has what? Reacted, definitely an examiner will indicate it in one way or the other. Am I communicating? Now, to get the valency of any atom, our interest is the number of electrons actually. Our interest is what? The number of electrons. But if you look at this question, what was given to us is number of protons. And I have stated consistently through this question review that number of protons is equal to number of electrons for an atom that is electrically neutral. I hope you're following, right? Therefore, it means that for this question, the number of electron is 3. And therefore, the valency of this guy will be 3. Since the number of electron is 3, it means that this atom in consideration in this question number 10 is a metal. It is what? A metal. And metals, their valency is simple. Let me just reveal a secret. Although we've treated it in class. But just for any of our friends that have joined us from anywhere, the valency of metals is always equal to positive the number of electrons in the outermost shell of that atom. Positive the number of electrons in the outermost shell of that atom. Okay, I'm coming back to this question number 10, please. The number of protons is 3. The number of protons is 3. So this guy has 3 electrons. And because it has 3 electrons, the valency is actually 1, not 3. Please, I correct my error initially. Option C is the correct answer. Option C, 1. This is 3 protons. And 3 protons means we are talking about atomic number 3. If you have 3 electrons, the first shell will carry 2 electrons. The second shell will carry 1 electron. And that second shell is the outermost shell for this atom. The number of electrons in that outermost shell helps us to get the valency. Question number 10. Proton is equal to 3. Proton equal to 3. The implication, it implies that electron is also equal to what? 3. Now, to get the valency, all you have to do is get the electronic configuration of this guy. The first shell, just for emphasis because of the mistake I made earlier, so I want to emphasize on this. Let's say that this is the first shell. It has 2 electrons complete. Now, the third electron will go to the outermost shell. So, this is the K shell. This is the L shell. Or you say this is energy level 1, N equal to 1. And then energy level 2, N equal to 2. So, if you look at this, the number of electron in the outermost shell is 1. And that is what helps us to get the valency. Anytime the number of electron is 1 or 2 or 3, that guy is a metal. And the valency is simply plus the number of electrons in that outermost shell. So the valency of this guy is plus 1. Once again, accept my apology for the erroneous move initially. Don't forget, I'm only a human, not above mistakes. But thank God I've corrected the mistake, and that's interesting. All right, so this is good. We've been able to do justice to 10 good questions, and of course, this is wonderful. Thank you all for joining the class. We are done with our chemistry class, and so we'll be moving on to review the questions posted by, I think, which group is that? By group 1 on English language. Yeah, group 1 on English language. This question was based on our class under verbs. On verbs in our previous English class. So we're going to give answers to these English questions, okay? Once again, the link is going to be dropped as I create the live stream class. Don't forget to like and share this video, okay? Leave your appreciation comment. And if you are not a channel member yet, assuming you are not our members in our physical class, you can join our online class by becoming a channel member. Click on the join tab below the video lesson. And then you can join the GMAETS 41 on the platinum package upward. in order to follow up with our classes. We have channel playlists for each of these subjects you are preparing for in your examination. Is it JAMB, WAEC, 100 level? We have works for you guys. See you in the soon to kick off English language class.